So some of the model evaluation metrics for regression are mean absolute error, mean squared error, and root mean squared error. For classification problems, we have only used classification accuracy as our evaluation metric. So in the next section, when we discuss classification problems, we will have a comparative study there. What metrics can we use for regression problems? The first one is mean absolute error, which is the mean of all the absolute value of the errors. Mean squared errors is the mean of the squared errors, whereas root mean squared error is the square root of the mean of the squared errors. And errors, again, is basically my prediction subtracted by my true value. So let's calculate these errors by hand and look how it turns out. So let's assume I've got two lists with me, y_2 and y_preds. y_true is the actual sales that happened, and y_pred is the predictions that our linear regression model made. Now let's take a shot at how to measure the errors for these models. So all we have to do is, we've already imported the metrics from scikit-learn module. We just have to call three corresponding functions, which is the absolute error, and then pass in our true value and predicted value. For calculating mean squared errors, we just need to pass again the true value and the predicted value. And the same goes for root mean squared errors, where we are calculating the mean squared errors and then using NumPy to calculate the square root. Usually mean squared errors is more popular than mean absolute errors because mean squared errors punishes large errors. What do I mean by that? So if you have an error, let's say in this case, if you take into account the first observation, the true value is 100 and the prediction is 90. What is the absolute error? It's 100 minus 90, which is 10. What is the squared errors? 100 minus 90, which is 10, and then square it up, you get 100. So you're basically placing a large bounty or a large penalty when you make a mistake. And that helps our learning algorithm to optimize better. But root mean squared errors is even more popular than MSE because root mean squared errors is interpretable in Y units. So let's look at some of the model evaluation techniques using train and test splits. Again, I won't be going over in great detail in this section. We'll definitely take this on the upcoming sections on what are the strategies on how to split your data into the training and test sets. So let's use train test split with RMSE to see whether newspapers should be kept in the model. So we have our X, which is nothing but our three features, our Y as the response variable, and then we use the train test split method of scikit-learn to actually split our data into training and test sets. And the reason why we do it is we will use the training set to fit our model, and then we will use the test set to predict on our model. So the test set is actually a set that the model has not seen before, and it would give us a fair idea on how the model does on data that it has never seen before. So we fit the data on the training set and then use the .predict function on the test set and then calculate the root mean squared errors. We get a value of 1.4. Let's exclude newspaper and try that again. Without a doubt, you see that the errors have gone down when we excluded newspaper. So that's another way to confirm which variables to use and which ones not to use. In the next section, we will be discussing handling categorical features with two categories.